Hey Internet, I made a thing! PathCam now supports loading Gerber files. Wait, but what does that all mean? Let me show you. Say you've created a PCB in your favorite PCB layout software, which is KiCad. The first thing you'll want to do is check the board setup. For isolation trace routing, you'll want clearances and track widths somewhere around 0.5 millimeter. Unless you have really sharp V-bit, I don't have any of those anymore because the inevitable flowchart of any CNC operation is crashing a bit into the table and them becoming not as sharp as they used to be. So 0.5 millimeters works well for me. The same thing with tracks and vias, 1 millimeter via outer size, and drills of 0.5 millimeter. Tracks can be about 0.5 millimeter as well. Once you've got something that you want to look at as a thing, you can go to the plot setup, choose front copper and edge cuts if you need edge cuts, and leave the rest of the settings as default. You can either check or uncheck the X2 format, either will work fine, and click plot. You can also generate drill files. Once the Gerber files are generated, you can open them up in PathCam. You can choose edge cuts for the board edge, the front copper for the top copper of the board, and the drill file for drill holes. On the board here, it gives you a context menu. If you click on the top copper, it'll give you the option to generate isolation routing paths. If you click on the board, it gives you the option to generate edge cut paths or change the board thickness. Whoops. And you can also delete them. If you want to, you can open up all the files all at once. It just takes a second to load sometimes. And you can move the board around wherever you want the G-code to be generated. So here, if I right-click and generate isolation traces, I get reasonable isolation traces, but I can also fine-tune the parameters here. The most important parameter is going to be the tool diameter, and the tool diameter might be 0.3 millimeters. Clear the paths, generate traces again. Now we can see the paths are closer to the copper layer. If I clear those paths, there's another option, which is the point span. If I want the points to be more precise, I can reduce the point span. And now I have more precise paths with more points, which means that sending it to a machine over G-code is going to take it's going to create a longer G-code file, but depending on your machine, that might be okay. You can also set the point span to a very large value. But it will by default add extra points around corners and tight edges to make sure that the overall geometry is roughly what it's supposed to be. A few good settings are 0.3 millimeters for the point span, 0.3 for the tool diameter, maybe 0.4. And to move height, this is how many millimeters above the z=0 plane the tool will move. As long as it's something higher than the PCB is tall, then it's fine. So the PCB is currently set to 1.57 millimeters. So we'll change this to 3 millimeters. Right-click and generate isolation routing paths. And once we've got the paths, we can send them over to a machine after saving as G-code. I'll just overwrite this file. And I'll take that file and load it up into a G-code viewer. And there we have it. But wait, you say, what's that tiny checkbox in the bottom left corner? Well, that's where things get really interesting. Checking this box opens up the robot connection control. PathCam can send G-code directly to a machine over serial. Specifically, a machine running Gerber and kind of Repetier. It doesn't not work. Clicking the connect button opens up a COM port form. We can choose whatever COM ports are available on the system. COM port 4 is connected to, well, let's find out. Connect, it'll run an automatic robot detection, which basically sends a query command for status from whatever potential robot is connected to it. And this one it thinks is a repetier machine. Let's connect to COM port 6. And try that again. And it thinks this one's a Gerber machine. The Gerber machine connection is actually a lot more complete than the repetier one. With Gerber, we can use the run, pause, clear, and resume functionality. I'll show you that here in just a minute. When we first connect to the machine is sending positions back. That's what this black cone is. This is representing the machine position. Let's try moving the Z position, so 1 millimeter up on Z, and there it goes, 10 millimeters up on Z, and there it goes again, somewhere up here. 1.57 millimeters is the board height, and here we can see that's level with the height of the board, so that is correct. You can change the board height if you need to, 5 millimeters or something like that. I'll change that back to 1.57. And tell the robot to go to a Z height of 0. If I were actually milling this out from a piece of FR4, I would set the Z height to 1.57, the same height as the board. And then I would use this offset box down here to bring the robot down to the surface of the FR4. So in this case, probably negative 1.57. More or less depending on exactly where the robot was located. When pathcam sends G-code commands, for example, a command to go to XYZ equals 000, it will also add this offset. So if I tell it to go to Z0, it will go to 000 and subtract 1.57 millimeters from the Z-axis, and the black cone represents the robot's final position. The silver cone represents the robot's position as pathcam is sending it without the offset. So what that means is, as we are running, if we need to offset the bit location higher or lower in the Z, all we have to do is change the Z offset box. So if I change this back to 0, as soon as it can, pathcam will send the updated commands with an offset of 0, and the machine will have an offset of 0 for the Z height. If we set an offset of 1, we'll see the machine move up to 1. You can also use the scroll wheel to control the position here. So as I scroll down, the position gets closer to 0, past 0. And this allows very fine control as the machine is running of the Z height. And that's particularly useful for isolation trace routing, where the Z height is critical. If the trace isn't being cut deep enough, it can easily be adjusted up or down accordingly. And for connections to Gerber robots, the pause functionality also works. You can pause at any point during the operation, resume, and that will just continue moving along the path it was already intended to go along. And when you're paused, you can tell it to clear. That will clear out all pending commands. It actually performs a reset for Gerber, and then sends Gerber back to the home position of 00 and whatever the move height is for Z. And we can run again from there. One note about the Z offset. The Z offset is only updated effectively when pathcam needs to send another line of G code to the machine, which means that when the machine is executing on long straight paths with no G code necessary, there's no update during that period. On top of that, there's also no update for however many moves are currently buffered in the robot itself. Right now, Gerber has a buffer of about 16 or 17 commands, and repetier is, I think, in the same ballpark. So that means for 17 of these little dots, no Z offset update will be sent because the 17 are currently buffered. We can improve that by using the uniform point functionality. If we set uniform points to true, clear the paths and regenerate the paths, that guarantees there's going to be a point at least every 0.3 millimeters. And we can increase that as well. 0.1 millimeters, clear the paths. And now we have dots spaced much closer together. And that means when we adjust the Z height, we'll have a much more responsive Z height adjustment. If we run this again, and this time I'll use the arrow keys on the keyboard to adjust the Z offset. And I'll bring it back up to 0. And here you can see it's updating closer to live. There's still a delay, but it's much more responsive than before. Using the arrow keys, the Z offset will go up by 0.01 millimeters for every arrow key press. Using the mouse scroll wheel, it will go up by 0.03 millimeters for every tick of the mouse scroll wheel, which might actually change depending on your system configuration. I think that's a number of lines scrolled equivalent. And connecting to a repetier machine is similar, except the repetier machine, especially this ancient firmware, it doesn't support the functionality for pausing and clearing. So I don't know what will happen if you use the pause and clear buttons. Probably don't. Yeah, that's just going to do nothing until I disconnect, which might hang something. Don't use the pause and clear buttons when connected to a repetier machine. So as PathCam is sending G-code over to the Gerber firmware here, the pins on the back are actually emitting step and direction pulses, which can be sent over to stepper drivers on a CNC machine of some sort. One moment, please. With the wires connected, and PathCam sending G-code over to the Gerber machine, we can take a look at what those pins look like. And just as expected, we're getting X pulses, Y pulses, X direction. I guess it was only going one Y direction during that time. And of course, Gerber's got its nice accelerations built in here. Decelerations. Stopping on the X there for a second, accelerating again on the X. Wouldn't it be nice to see that in an actual CNC machine? As it turns out, this happens to be a CNC machine right here. So let's see if we can make this 3D printer a 2D printer. So over here is an ancient 3D printer circa, 2011, running some ancient version of the repetier firmware, version 0.9, I believe. But it still 3D prints just fine. Let's see if it can 2D draw as well. I've got a pen stuck in behind the fan, and we can connect it over to PathCam and send some G-code and see what happens. So for this particular machine, it does help to have the consistent points, but 0.2 millimeters apart is a little bit too close, so move them to 0.4. Otherwise, we'll just get very slow motion due to all the excessive G-code commands being sent. Clear the old paths, add new paths. That looks about right. And I guess it was already connected to it. Connect with the same baud rate, it'll detect and say repetier, which is great. And right now I don't have the stepper motors powered on, so I'm going to tell it to go to 0 and 0, just so I know where everything's at. So it should have already completed those commands. I will fire up the stepper motors. By the way, before the motors are started, I can move the X and Y around to position the start point wherever I want it to be. And once I get it in a ballpark where I think is good, I'll fire up the stepper motors. Now if I use the ZGO command, it should move the Z-axis. Hey, look at that. And let's move it back down to, let's move it to 1.57, which is the same height as the board height. And we want 1.57 to be exactly the same as the surface of the paper. So let's move it down 4 millimeters. A little bit further than that. So one trick, if I keep the mouse hovered over the Z offset box, I can just use the scroll wheel to fine adjust the Z height here. So we'll put it somewhere where it looks like the pen is on the surface of the paper. And at that point, the surface of the paper should be at what the machine thinks is 1.57 millimeters, or the surface of the board where the isolation trace routes are. And we can just hit run and see what happens. Uh-oh. That was way too far down. But luckily we can adjust it on the fly. Move it up a bit. It's probably better to start higher than lower, especially with isolation trace routing. And we can use the keyboard too to up-down arrows on the keyboard to increase or decrease the Z offset. So if I press the down arrow a few times, the pen gets closer to the paper. Not writing quite yet. There we go. So now we're just barely touching the surface of the paper with the pen. And with PCB isolation trace routing, one of the trickiest parts is getting the Z height set correctly. Too low of a Z height and your routed paths are wider than they are supposed to be. Too high of a Z height and you don't penetrate through the copper layer. So having this fine adjust feature, having this fine adjustability while the machine is running is really convenient. Coffee time. And just out of curiosity, let's turn the steppers off, give it a fresh chunk of paper to draw on, and try a slightly different point span. So this is running in real time with the extra points turned off, so there's a lot fewer lines being sent over to the Repetier firmware, which means it can handle things a lot faster, but it'll be less responsive for Z-height adjustments. I guess the next thing to do is print a spindle holder for this thing and see how it does on real copper-clad FR4. I used a Dremel with V-bits before, and that works pretty well. I'm not sure how the frame of this 3D printer will hold up to holding up a Dremel though. It doesn't take much to cut out isolation traces, so a smaller spindle would work too. It just needs to have good bearings with low runout. Why even bother with routing isolation traces at home though? PCB manufacturers like PCBWay provide great high quality boards, not that this is an advertisement, but it takes about a week to get them. So that doesn't work very well for prototyping simple one-off designs. Breadboards are great for those sorts of things just until high frequency or high power come into the picture, at which point building a circuit on a perf board is the way to go. And that's exactly where I found utility in isolation trace routing. It's much easier to lay out a board in KiCad and cut the majority of the traces on a machine than to solder every trace as a jumper on a perf board. It also makes using surface mount components much easier, particularly SOIC and QFP packages with 1.27mm or greater pin pitches. As for pathcam, you can get it from the GitHub page in the description below. It can be built from the source on either Windows or Linux, and there are built binaries available in a zip folder as well as a .msi for Windows. If you have any questions or ideas for more features, just leave a comment or create an issue over on the GitHub page. I'll probably upload another video of pathcam being used on an actual CNC router to mill isolation traces at some point. It might just be a 3D printer with a spindle tied to it though. Happy isolation trace routing, everyone!